This doesn't look like a GPU that I would be remotely interested in, does it? Look at it. And yet, here we are. More importantly, I'm surprised, stunned even. This little thing is actually probably one of the most important GPUs that Nvidia has done in the last couple of years. This little thing. This is the Nvidia RTX 4000 ADA generation small form factor. That's their official name for this GPU. I borrowed it from somebody who has acquired it for other purposes. And they said, you really need to see this. And I said, why? Why would I need to see it? Do I need to poop on it? It's a great GPU for me to poop on. But holy crap, this card actually is kind of a holy grail of my fantasy wish list of features that I've had for a card for a long time. Not just for the lab or a workstation use case, but also kind of like, it's got a lot of compute horsepower, and it's got 20 gigabytes of VRAM, and it's got 4 DisplayPort 1.4 connections. It doesn't need external PCIe power. It really checks a lot of lists that have been on my shortlist for a long time. And this system is a 12-core AMD 7900 system. Very low power, and I've also got Cooler Master's very efficient 800-watt SFF power supply. Let's take a closer look. This is the epitome of low power computing, but lots of horsepower. So everybody in our forum is buying 4090s for their AI stuff. Well, also even 3090s, like there have been a couple of cases where people were trading 3090s to get the NVLink Bridge 3090, so you can have 24 gigs of VRAM from two 3090s. I saw one case where they traded a 4090 to get the matching 3090 and NV Bridge. I mean, but this thing can actually run a 13 billion parameter model at 25 tokens per second in 70 watts. I'm going to show you how to do that in the software stack in this video. You can use the chapter markers to figure that out. But let's talk about that because that's kind of a big deal. 25 tokens a second, 70 watts. I mean, what about home lab use cases? People are picking up older GPUs like the 2080 Ti and unlocking the number of sessions that you can have on them for the encoders and the decoders, and then using that to power their media servers for transcode and streaming and everything else, you name it. Well, this is the one card that can do it all out of the box and also supports unlimited numbers of encode and decode sessions. That's not unlimited performance. That's just unlimited sessions. That's an important difference. So this thing also supports AV1. Yeah, AV1. This one little thing in 70 watts with a fan and it doesn't even run hot. Now this or the 4090, I mean, they cost about the same. That's kind of the downside here. This tiny little thing costs as much as a 4090. You're going to buy this over the 4090? That is kind of a tough part here, too, when you think about it, because, well, I mean, the 4090 gives you 4 more gigs of VRAM, and it's pretty good, except it uses, 400 watts, but also the Quadro software stack, and, there's trade-offs. I mean, if you were targeting using this as a display and you want to run 8K or 16K displays that use multiple DisplayPort connections, you need to ensure that the giant display renders everything from left to right, top to bottom, as it should across all displays. You get into, it's like, well, there's other features you need on your GPU that are just not there in gaming GPUs. This also has the 3D stereo sync connector, supports NVIDIA Mosaic. These are things that are harder to get in the RTX gaming scenario. It's easily noticeable if you're looking at a matrix, 4x4 matrix of displays, and one of the displays is slightly ahead of or behind the other displays. Plus professional software like Autodesk support and simulation support, and that whole barrel of complication versus a gaming GPU. I mean, otherwise, yes, the 4090 with its 4 more gigs of VRAM and somewhat higher computational horsepower would make a lot more sense dollar for dollar. But it's also 400 watts and a giant card. It's 70 watts with 25 tokens a second and a large language model. This GPU has 19.2 teraflops of single precision performance, 44.3 teraflops of RT performance, and 306.6 teraflops of tensor performance. If you want to run tensor core stuff on here, that's an option. PCIe Gen 4, 16 lanes, and 20 gigabytes of VRAM. I mean, if you don't need a lot of actual GPU horsepower, 20 gigs of VRAM, that's kind of a lot. 280 gigabytes per second of memory bandwidth, 6,144 CUDA cores, 192 tensor cores, and 8 ray tracing cores. It can drive 2 8K displays or 4 4K displays at 120 hertz. And yeah, this thing beats the 12 gig Ampere A2000 in just about every measurable way. The A2000 is already obsolete. Ampere, no. Yeah, it is. Well, let's talk software setup and what you need to do to replicate our setup. Now, okay, for the setup, I'm going with Ubuntu, and I've done a write-up on the forum, and you can follow along on the forum. I've actually had better luck with Arch Linux, especially on the CUDA side of things. You see, with the Blackwell generation incoming, I think NVIDIA, it seems that NVIDIA has changed a lot of stuff on the hardware side that I don't fully understand yet. I went to NVIDIA GTC, and I got to see behind the curtain on a lot of things. And it seems like NVIDIA is leveraging the cohesion of their CUDA ecosystem in order to really change pretty radically under the hood the hardware in Blackwell. And so they're abstracting a lot of that away from we, the programmer, we, the people that would use this on their platform. And this is, again, ADA generation. So this is not the Blackwell generation or anything like that. Maybe mixing and matching CUDA versions. There could be some rough spots coming for the future. I don't know anything about that. But right now, today, when we're talking stable diffusion and large language models, it's pretty solid support. And so Arch Linux, being at the bleeding edge of all of that, is going to be the first place that you trip over that. But when you're looking for other references on the internet, a lot of the other guides are written for Ubuntu. So I've written this guide for Ubuntu 22.04 long-term support. Now, if you're following along for the how-to, you really should just go to the forum and step by step. But you get Ubuntu installed, and it's got the NVIDIA drivers, and you just run Docker PS. Docker is not a valid command. You could apt install Docker, but don't do that because we need the community version of Docker. You want to also make sure that the system is fully up to date before you do any of this. Once you follow the installation how-to, you can do docker run hello world, and that should give you hello from Docker. This message shows a bunch of interesting stuff. NVTop is like top, but for the NVIDIA GPU service, and then you can run NVTop and you can see if it detects the device or devices you have in your system. In our case, it sees everything. It sees 20 gigs of VRAM, it sees the temperature and everything else. We'll come back to that. That's great. So the next thing we're going to do is install Ollama. Now, Ollama is not the end-all be-all. It's just, and in fact, it's a very modest starting point, but in terms of like the democratization of AI, it is a great starting point because it's got some readily downloadable models and you can really get started with it. And we can just dangerously curl install a shell script. You never want to do this. You can do the manual install so that you can see what it's doing, but this system for me is ephemeral and going to be thrown away. So I'm going to live a little dangerously and just dump a shell script into the shell. But I do like that they have a manual install link on their webpage. The manual install explains what it's doing. Also notice that on our system here, it says AMD GPU dependencies installed. That doesn't mean that the NVIDIA dependencies are not also installed. It's NVIDIA by default, but it just got support for AMD GPUs. And there is technically a modest AMD GPU in the iGPU of our AMD 7900 on our test platform here. With this, we can run the Ollama command. You can do Ollama pull and pull in some models. We'll also be able to do this through the GUI later, but there is one other configuration change we have to make, and that is the systemd service file. We're going to tell Ollama to listen on the local network. Now, if your local network is dangerous and you don't want randos connecting to your AI service, probably don't do that. But we're doing that here so that Docker has an easier time to connect back to the host that this is running on, because we're going to put a web GUI on our Ollama model. So understand what's happening here. Ollama is running at the system level as a service. And you can access it from the command line here. Like if you want to run Ollama from the command line and interact with it purely from the command line, you can now do that now that it's installed. You just need to pull a model. I want a fancy web GUI though, so we're going to install that. And the web GUI runs in a Docker container. The Docker container needs to be able to connect to the actual AI service connected to the hardware, which it will do over the network. And so we need to configure our systemd service file using the environment variable. We're going to add another environment line, and we're going to set Ollama host to be 0.0.0.0, which is the IP addresses it listens to. Now, if you prefer, you could specify a Docker interface here, a 172 IP address, chances are, and only allow Docker containers to connect to your Ollama service, but it's on a LAN connection here that is reasonably safe, so I'm going to just let it listen on 0.0.0.0. Ollama pull Dolphin coder, for example, for coding help, AI coding help. Yep, we'll just go ahead and do that. And then we can go to the web GUI how-to, which is also linked in my how-to, and just run a single Docker command, which will pull the web UI. It'll automatically restart when you restart the system. Remember, Docker PS will show you stuff that's running, and then we'll be able to access this on our LAN IP address of the system, /3000, port 3000. The first account you set up, You can give it an email address and a password, and it doesn't actually need to connect to the internet. You don't actually have to sign up. When you sign up, you're signing up with your local instance, so you're not really doing anything crazy here. If there's a problem with the connection or a problem with the networking step, or you didn't restart the systemd service, then it won't be able to connect, and you won't see any models, even though we already downloaded a model. But you can hit that little gear and go to the models tab and reconnect, and you'll be all set. When in doubt, restart, although you can just restart the service from the command line as well. With the web UI connected, it'll show Dolphin Coder in the drop down at the top, and it's like, hello, I would like to write a Python program that can search for numbers that are perfect. It's not a lot of words. It's going to generate a lot of words. And while it's generating a lot of words, we can go and check our CPU utilization and our GPU utilization and how much VRAM is being used and all sorts of fun stuff like that. I love this model because it's just big enough that it's not going to run properly on 8 gig GPUs. Hey, look at that, 628. 496. We're off to a pretty good start. Although if you notice, the first response I got from this algorithm, it's searching for odd perfect numbers, which if we find an odd perfect number, we will make a lot of money. Let's ask the AI about that. Does it really make sense to search for odd perfect numbers? Are you that ambitious? I don't think it understood that. Let's tell the AI that we can make a lot of money and be famous if we find an odd perfect number. So that while it's busy composing our response, we can switch over and see that it's using about 9.47 gigs of VRAM out of our 20, almost 20. And temperatures at about 65 C, and the fan's running at about 34%. We are using all of our 70-watt power budget. Now keep in mind that 4090 is about 3 times faster here, but this is still a shockingly good and usable result. For comparison, let's do the same set of prompts on the 4090 and just see how it performs. Yeah, so basically we're looking at 25 tokens a second versus 75 tokens per second. But keep in mind the power usage here. So that 4090 is consuming, 350 watts and change. This thing's running at 70, and we're getting a third, 33% of the performance, and we're not at even a third of the power. So in a nutshell there, the 4090, 3 times faster at 5 times the power utilization. Now, you could underclock the 4090, but is there anything else that the AI can think of that would be relevant to our discussion of perfect numbers? I don't think so. But it is useful for generating a lot of output. All right, from here, you can have a lot of fun with Ollama, downloading models, configuring it, doing other things. You don't even have to use Ollama to run large language models. This is just one way to run large language models. Let's get Automatic 1111. Automatic 1111 is a stable diffusion web GUI. Now, Automatic 1111 has some warts, and there's a lot of people that are doing a lot of really interesting, awesome stuff with Automatic 1111. So I found this random GitHub repository that has some nice quality of life enhancements to Automatic 1111. And for the purposes of this video, we're going to run that one because it also sets it up in Docker. So running it in Docker means that you don't have to do nearly as much stuff on your local system. In fact, there's a really old to do on the forum that I did a long time ago, not doing it with Docker. It did not age well. This is something that aged a little better with Docker. And so when you run the commands there, you can see that it will connect to Hugging Face and download a basic Stable Diffusion 1.5 model to start with, set up the web GUI. That's going to be running on a different port. That's going to be running on port 7860. And in case you're wondering, you can run Ollama and Stable Diffusion at the same time. Stable Diffusion, most of the models really don't use a ton of VRAM. And you've got 20 gigs of VRAM on this card, which is kind of a lot. So you can run both of them at the same time. If Ollama needs more VRAM, you can use Docker, stop and then the container name, and that will free VRAM. You can also use systemctl Ollama, stop Ollama to stop the Ollama service, which will also free any VRAM that Ollama is using. The nvtop command, remember, you can run that and see what processes are being used at the bottom. Once you run through the how-to for Automatic 1111, it too gives you a web GUI, and you can experiment from there. You can even use that to download new models, or you can use wget to install new models from the command line like this. And when I use wget from the command line here, it wasn't a lot of fun because I had to rename the file because I got all the trailing gobbledygook after it, but hey, that's okay. This is what the Stable Diffusion web GUI looks like. As always, just do a quick sanity check and make sure that Danny DeVito and his robot cat Spangles is going to run. It does. Pretty good for a near instantaneous response. Let's use our AI chat model to write a stable diffusion prompt. These are not great prompts. And we can see we've increased the VRAM utilization a little bit from our NV top view. We're still well under a 20 gig limit. And it's making some pretty reasonable output at 512 by 512. There's Danny DeVito as Radagast the Brown, standing in front of an imposing treehouse adorned with ivy-covered windows that seem to dance in the breeze. Pretty sure that none of that language actually helps the prompt, but that's cool. Here's a prompt literally taken from Civit.ai and a new model that I've downloaded. But you can download a new model through the GUI. Now, this Docker thing set up, the sky's the limit. You can run other Docker containers. Plex Media Server, Jellyfin, whatever you want to run, is available in a Docker container. All you really need to do is check to see if your Docker container supports NVIDIA hardware acceleration. Remember, we installed the container tools as part of the how-to, and because we installed the container tools, NVIDIA is hooked into Docker. And this machinery is also kind of how it works on Windows. Like, I did a really amazing video with the Falcon Northwest Intel workstation video a long time ago, and same NVIDIA hardware with the 4090. And that is a great platform for doing the same kind of thing. Even under Windows, not natively Linux, you can run all the same Docker commands and everything else like that under the Windows subsystem for Linux, running Linux kind of sort of under Windows. NVIDIA has done a lot of work to make their tooling available on Linux, and the installation method for these CUDA tools on the Windows subsystem for Linux is way different than bare metal, because what runs on the Windows subsystem for Linux is a lightweight wrapper that passes through the commands to whatever's running in Windows. And NVIDIA is getting to the point where that is sort of the preferred way of interfacing with the hardware, so that it's kind of homogenous between Linux on bare metal and Linux under the Windows ecosystem, because for software development and these sort of bleeding edge things, the experience in Linux is far more coherent than what you get in Windows. And also Linux is much more pervasive than Windows for these kinds of use cases, which is interesting and awesome, but also interesting. So fun, interesting times and situations that we live in. So with this CUDA setup, you can really do a lot. And yeah, if you have the power budget and physically room in your case and blah, 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 yeah, you could buy 4090 for all of this, but it's not exactly the same feature set as a Quadro. Like, that's really what it comes down to. And like professional software, if you need support from third parties, they're not going to give you support generally for gaming class GPUs. And the fact that NVIDIA is doing this in 70 watts, I really hope NVIDIA competitors sit up and take notice, because this is something I've been asking for 5-10 years. And this is amazing performance in a 70 watt power envelope for large language models and image generation, and of course, professional software and everything else like that. And yes, it is a third of the compute resources of a 4090, but with 20 gigs of VRAM. So in a 70 watt power envelope. I mean, you could get 3 of these and you would still be at what? Not even half the power budget of a 4090 and the same performance. That's something. And here's our system power running those math questions. Basically, we're looking at full CPU utilization, full GPU utilization. This is our 70 billion parameter model, so it's going to be using even more power. I decided to ask the model about perfect numbers and to write a Python program to compute perfect numbers because, well, it would generate a lot of output and would have to draw on a lot of knowledge in the model. One trick you can use in your own AI prompting is a phrase like, think carefully about your answer, or take a moment to think before responding. There are probably no odd perfect numbers, but the first time I asked the model, it didn't even bother to skip odd numbers when providing an example program to do the search. Basically, it was just, let's increment a number, do a search, increment a number, do a search, which is kind of the most facile way of searching for a perfect number. And you'll be happy to know that during our worst torture testing, our reported GPU temperatures were pretty consistently around or below 70 degrees C. Sometimes it would spike up a little past 70, but then the fan would ramp up and it'd be pretty good. The NVIDIA RTX 4000 ADA generation SFF edition GPU is the greatest option for running simpler LLMs and doing normal professional compute you do with a Quadro instead of a gaming RTX card. If you need a card that is either very low power or not super heavy on the compute side, but you've got all the memory bandwidth. And before you get any ideas like shoving this into a NAS, you should know that most NAS appliances are designed to support at most a 25 watt PCIe card, not 75 watts, as this one requires from the slot. It'll also require a double slot. Physically there needs to be room there. There's also the PNY version of this card is bundled with both a half height and a full height bracket. Also note the 4 DisplayPort connectors at the back are mini DisplayPort, and almost every mini DisplayPort cable on Earth that I've tested for the KVMs and everything else is cursed and has a terrible time delivering the full line rate DisplayPort 1.4 connections. Oh, and in case you're wondering, it does not support vGPU functionality, officially or unofficially. It won't do NVLink either. For unlimited encoders and decoders, when we actually get down to it in the testing with Plex Media Server and Jellyfin, the performance fall off is non-linear and pretty significant. I mean, you can do 4 or 5 streams, I think, with Plex, no problem in realistic scenarios. There are 2 physical hardware encoders and decoders, but the unlimited number of sessions is going to be diminishing returns, really diminishing returns, much past about 4. I mean, it's a different story if you're taking something like a premium 4K stream and compressing it down to 720p low bitrate for mobile. So it's really hard to do an apples to apples explanation about what your expectations should be if you're coming from, say, 8 streaming sessions running on a 2080 Ti or something like that. I mean, this card is better in every way, at least every way that I tested. And it has full AV1 support. So that's also pretty exciting. So yeah, color me both surprised and impressed. Like, I get the cost. I mean, in the cost universe of Quadro cards, this is pretty good. I imagine that if you were buying a Quadro or a workstation card for something like Revit or doing cabinet things or simulation or whatever, you'd probably want more compute horsepower. But for running large language models with 20 gigs of VRAM in like the ultimate home assistant appliance, if the cost premium doesn't mean anything to you, then this is in a class by itself in terms of 20 gigs of VRAM, memory bandwidth performance, and the fact that it's doing all of the stuff that it's doing in such a tiny 70 watt package. If you can run a 4090 and you're a hobbyist or a home user use case, or you want something really amazing for Home Assistant, the 4090 is almost certainly going to be a better choice in all respects except one, that is power usage and physical size and idle temperature, because this thing idles pretty cool as well. That's not always true with the 4090, especially the reference edition of the 4090. A version like the MSI Supreme 4090, idle temperature, not going to be much of an issue, but those cards do idle significantly higher in terms of power usage than what we see with this. So truly mind-blowing that we can get a large language model to run as fast as you saw on a card like this, on a platform like this, which is designed for very low power. Our 80 Plus Gold power supply plus the 65 watt 7912 core on a full server AM5 platform, optionally with error correcting memory. Now, the error correcting memory on this platform, it's AM5. Theoretically, the hardware is there in newer versions of the Linux kernel. We just got it, but Ubuntu 22.04, I don't think you should consider the unregistered UDIM error correction support in AM5 to be fully baked in the Linux kernel. That's a whole other discussion on the Level 1 forum we can get into. But overall, this platform is very stable, very well put together, and relatively inexpensive for what it is. Like, if you wanted a 10-year appliance to do, video analysis and have an interactive large language model in Home Assistant, this is a great solution for that. Even considering that, versus a gaming GPU, there might be a bit of a price premium with your NVIDIA Quadro card. But with the Quadro, you're getting some things you don't get no matter what you're getting on the gaming GPU side of things. And that's even stepping outside of NVIDIA and going with a non-NVIDIA solution. So NVIDIA really does have something special in this card. And what this Level 1 has been a quick look at the RTX 4000 small form factor ADA generation, official name, card from NVIDIA that I borrowed, that is not from NVIDIA, that I didn't expect to like as much as I do, but gosh darn it, this is a really innovative piece of hardware. I'm signing out. You can find me in the Level 1 forums. Let me know if you want me to take any more stuff for this for a spin. I borrowed 2 of these cards, but I have to send both of them back, so I don't have a lot of time. So if you want me to try anything, let me know, because it might be a lot of fun. All right, I'm signing out, and I'll see you there.